we will be looking at the meeting rooms 2 problem and build a solution in JavaScript using a two-pointer approach. Let's first understand the problem statement. We will be given an intervals array that will be having values corresponding to the start and end times of meetings. For example, let's say interval, we have an array that says entry of 0, 30. That means here is the starting point and this is the end time. So it starts at 0, ends at 30 minutes. This meeting starts at the 5th minute and ends at the 10th minute. This meeting starts at the 15th minute and ends at the 20th minute. Basically a span of 5 minutes. This also has a span of 5 minutes and this has a span of 30 minutes. From this, we have to now figure out what is the number of meeting rooms that are going to be required for all the meetings to be conducted successfully. We know that for every meeting, a room is required, and if the meetings are going to be overlapping, then they cannot be held in the same room. So that's why they will require a separate room. But if a meeting ends and then the next meeting starts, in that case, we don't need two separate rooms. The same room can be used for both the meetings. And that is the catch here, that we have to see if a meeting is going to be ending and then the next meeting starts. In that case, whatever number of meetings you had and the equivalent number of rooms that they would require gets reduced by 1, because then a room can be reused. So the main aim here is to see for how many meetings the room can be reused, and if it can be reused, then the number of rooms gets reduced. And we are going to identify the ending event here, and the ending event is going to be represented by this values in the inputs that we have received. And whenever an ending event occurs, we know that if we see another meeting that has a start time which is going to be greater than the ending of the current meeting that you have, then the number of rooms that are going to be required gets reduced. So basically we will say if you have 3 meetings, we will need 3 rooms. But if another meeting is going to start after one meeting ends, then the number gets reduced by 1. And we will keep checking for this number throughout the input that we have received. And because of that, because we are relying on this ending event, I will need to separate out this ending events into a separate array from the starting events that I have. And to do that, I will say I will be having a start array and I will have a end array. I will put all the start values in the start array and all the end values in the end array. We don't care about which meeting has started at what time and at what time it is ending. We are just bothered about whether a meeting has ended and is there some meeting that will start after that so that the room can be reused. And to do that, I will just say put 0, 5 here and 15 here in the start array that we have. And in the end array, I will just put 30, I will put 10 and I will put 20. Now I need this to be sorted in a chronological order, because then I know the correct sequence of meetings that is going to be running, and after one meeting the next one starts, then I will reduce the number of rooms. And to do that, I will just sort this. So if I sort, it becomes 10, 20 and 30. This one is already sorted. We'll be using 2 pointers. One pointer to keep track of this start array that I have with me. So I will have a start pointer and I will have a end pointer pointing towards my end array. Now we said that whatever meeting is going to be conducted is going to require a room. So I will say the number of rooms required is going to be depending on this start array that I have. So I will just keep on going through this array and I will keep incrementing the number of rooms that I require. I will say I'm here. I need 1 room for this meeting to happen. Then I will move my pointer ahead and move forward to the next value. So now start pointer will be pointing here. Now for the second meeting, I will also require another room. So 1 plus 1 becomes 2. At this point, I am going to say I require 2 rooms for the 2 meetings that I have that needs to be conducted. Now I will move forward again, and this pointer will go to the last entry. So the starting pointer is here. Now I will again say that yes, for this meeting to happen, I require a room. So I basically need 3 rooms for 3 meetings if they are going to collide with one another. Now we have to see whether they collide with one another. We will be basically checking if any other room has been made available from the rooms that you currently have. What I mean by that is room available is the check that I'm going to be doing every time. And how do I know if another room, we don't care about which room has become available, we just want to know if some room has become available. And how do I know if some room has become available? Is that if this meeting that is supposed to start at 15th minute is starting after some other meeting has ended. It can be any meeting. We don't want to track which meeting has ended. We just want to know that, okay, some meeting has ended. Then I can say that I can reuse an existing room because that room was being occupied. That I will just compare my start pointer with my end pointer here. So I will say, is this meeting is started at 15th minute? Is it greater than the end of some other meeting? So this meeting was supposed to be ending at the 10th minute. So if a meeting is ending at the 10th minute and your meeting is starting at the 15th minute, that means the room that was occupied previously has now become available, and we will just subtract that room from the number of rooms that is required. So now the rooms that are supposed to be used become 2 because 15 is going to be greater than or equal to 10, and 10 is the end, 15 is the start. And if this happens, you just reduce the number of rooms that is required, and we have reached the end of our input. We are left with the rooms that are supposed to be used as 2, and the output is going to be given as 2. Now let's convert whatever we covered so far into code. We said that we are going to be returning the number of rooms that are going to be used and the minimum number of these rooms as part of our solution. So I will say let rooms used be 0 at the start, and I'm going to just return the number of rooms that are going to be used. And let's also handle a edge case wherein if you have not received any intervals, then I can just return 0 because then no conference is going to happen. Then we said we will be basically checking whether rooms are available or not based on an ending event. And to keep track of this ending event, I need to split my input into a start and an end array. The start array will keep on seeing how many meetings rooms we require for the meetings that needs to be happen, and the end array will be checking for this ending event of a meeting. And I can just say let start is equal to a new array, and this array can have the length of my intervals that I have. And similarly, I will keep track of the end times using a end array. Now I need to start filling into this start and end arrays, and to do that I will just say let I is equal to 0, I go up to my intervals length I plus plus, and for the start array at the ith position I will just say the value is going to be intervals of I and 0 because the first value is the start time and the second value is the end time. And for the end time, because the second value is going to be the end time, I will just say 1 and I will say end here. So that populates my start and end arrays. Now we want this to be sorted in a chronological order because we are going to be comparing the start time and the ending events, and then the ending event we will say, hey, is the room become available? The room will become available if you have another meeting that is started after some meeting has ended, and because of that we need to have that in the correct chronological sequence of how the meetings are going to happen. And to sort, I will just say start dot sort. I will say a comma b and just a minus b. So this will sort the start array in chronological order, and similarly I will also arrange my end array in the chronological order. After I have sorted, what next? Now let's check how many rooms we will require if, let's say, none of the rooms can be reused. In that case, let's have a start pointer. This start pointer will be pointing to my start array, and I will say while my start pointer that I have is going to be less than the intervals dot length, keep incrementing the start pointer. So I will basically keep on going in a loop until the length of my start array that I have, and let's say we keep on incrementing the number of rooms that we require every time. Now let's ask ourselves, is a room going to be reusable? If we just follow this logic, I will start from here. We will have 0, 0, 1 room is required. Then a meeting starts at the 5th minute, another room is required. A meeting starts at the 15th minute, another room is required. And I just keep on incrementing the number of rules. Now we will check whether a room can be reused. And to do that check, what we will basically say is whatever value you have in your start array, that is the starting time. Try to see if an ending event has occurred before this. And how we will check that is, we will see within my end array a meeting has ended before the next meeting has started. We don't care which meeting, we just care some meeting has to be ended before this meeting starts, because for that some other meeting to have ended, that would mean that it was already started at some point in time and now it has ended. And because it has ended, a room has become available. And if the room becomes available before the start of my next meeting, which is, let's say here, that means I can just reuse the room. And reuse the room means I will have to reduce the number of rooms that are going to be actually required. And that will translate into, if the start array, whatever value we have, so that is the value of the start of a meeting, is going to be greater than equal the meeting that has ended, some meeting that has ended. And if that some meeting has ended and then you are going to start your meeting, a room becomes available. And I will have my end pointer with me, and I will just say within the end array that I have, compare with my start. So if your meeting is starting after some meeting has ended, then a room can be reused. And to do that, I will just say, so initially what I was doing, I was just saying increment the number of rooms and just increment the pointers. Now I will say increment the end pointer, because now I have already covered one end time within my end array that I have. And the number of rooms, instead of getting incremented, will get decremented, because this is where the reuse aspect comes into picture. And that's pretty much it in terms of implementation. We will go through the entire length. We will see if a room is going to be required, that is going to come from the start time array that you have, because that indicates that some meeting is going to be starting. And then we will check our reuse logic if a meeting has ended before your meeting starts, because that just creates a case for reuse of the room. Now let's see the time complexity that is going to be involved here. In terms of time complexity, we go through this intervals input that we have with us. Let's say the time complexity that is going to be involved here is going to be big O of n, with n being the length of the intervals array that you have received. Then we are going to be having time complexity for sorting, which is going to be n log of n for both the arrays that you have received. So both of them are going to say use n log of n time for the sorting purpose. Then we again go through this intervals array here that we have here, and that will just say time complexity of big O of n, because the start array is going to have the length of intervals itself. That's why we said the array is going to be initialized with the length of intervals itself. And then the overall time complexity that is going to be involved here is just going to be reflection of all the time complexities that are going to be involved. So we will say big O of n plus big O of n log of n plus big O of n log of n plus big O of n. Now from this we can say that n log of n is comparatively very high in comparison to log of n. and then we can just ignore this log of n time complexity, and that's why the overall time complexity becomes n log of n. And you will say n log of n plus n log of n, which gives us 2 n log of n, 2 being the constant, we just skip it. That's why it is n log of n. And in terms of the space complexity that is going to be required, that is going to be big O of n. Why big O of n? Because the space complexity with respect to start is going to be big O of n, because that's the amount of space needed equivalent to the length of the intervals array. And for the end array also, it's going to be big O of n. That's the equivalent space of intervals array that you have. You will say big O of n plus big O of n, which gives us big O of 2n. 2 being the constant, you're just left with big O of n. And that's pretty much it. Thank you for watching.